Student, this is a continuation of our last lecture where we were learning Newton's second law and we were doing problems on Newton's second law. So, we are doing few more problems on Newton's second law. After that, we will continue to our Newton's third law. Okay? Yes. Let's see problem number 1. A 600 kg rocket is set for vertical firing. If the exhaust speed of the gases is 1000 meter per second, find the mass of the fuel burned per second to supply the thrust to overcome the weight of the rocket, right? Yes, few things are given to us. The mass of the rocket is given 600 and the speed of the gas is also given 1000 meter per second, and we have to find what is the mass of the fuel burned per second. We have to calculate to supply the thrust to overcome the weight of the rocket. So, two things I have discussed with you if you remember about rocket problem. This rocket can be flying with acceleration or without acceleration, right? Yes. So, here is not, they did not say anything about acceleration, they just want to overcome the weight of the rocket, means it is not accelerating, right? Second case, two cases I have discussed with you, if the rocket is accelerating or not accelerating. So, if you forget, then I am telling you, if rocket is accelerating, then how you write the net force on that? You write V into dm by dt, correct, minus mg is equal to what? Ma. This is the equation you write when rocket is accelerating. But in this question they said that we just want to overcome the weight of the rocket, means not accelerating, okay? Yes, it means what equation, right? We write this much equation only, right? Ma is what? 0 term. Okay, also should give attention here, if I forget to tell you, this V is always what? Relative velocity of the gases with respect to what? Rocket, okay? Yes. So, we will use this formula here, okay? V dm by dt should be equal to what? Mg. So, in this question what they are asking us to calculate the amount of the fuel burning, okay, mass burning per second, means dm by dt we have to calculate. As I told you, in rocket the main mass is what? The fuel mass only, okay? Yes. So, we have to calculate dm by dt, okay, is here, this we need to calculate, which is equal to small m by what? V. This m I can call it mass of the rocket, okay, capital M. So, mass of the rocket is already given 600, g we know 10, and velocity is given what? 1000, right? 1230. So, 6 kg per second, that is the rate of the fuel burn to overcome the weight of the rocket. By chance, here they say like how much fuel should burn so that the rocket flies at some acceleration value is given, suppose it flies at what? 5 meter per second square, right? In that case, the complete equation will not be this, you have to write equation like this way, V into dm by dt minus mg is equal to what? Ma. This equation you will write, right? Because here rocket is accelerating, but in this given question is not accelerating, just we want to overcome the weight of the rocket. If they say the rocket is accelerating, then you will write this equation, not this, right? There are two ways to solve the problem on rocket, okay? Yeah. Also give attention, I am telling this V is the what? V is always relative velocity of gases with respect to what? Rocket, okay? Be careful about that. Okay. Let's do another problem, which is here. A cricket ball of mass 150 gram is hit by a bat so that it returns back with what? Same velocity of what? 10 meter per second. Ball was coming with this speed of 10 meter per second, you hit it, it rebounds with what? Same speed they are saying. Its speed also can be different, doesn't matter. Okay. If the time of contact is given with bat is given 0.01 second, find the force exerted by the bat on the ball. So, this is your bat and ball was coming like this way, it rebound like that way. Suppose goes straight, it can be a different angle also. Yesterday I have discussed the question whether the angle is given, right? Angle is given, then you take component in what? X direction, Y direction. I will discuss one more example with you, okay, if you not understood. So, this was coming with momentum some mb, returns back with what? Momentum minus mb. I wrote negative because direction changing, okay? Yes. If you call this positive, then this you can call negative. If you call this negative, then that will be what? Positive. This is your P initial momentum, this is your P final momentum. Okay, let us calculate change in momentum, del P. P final minus P initial, you say minus mv, what is the answer? Minus 2 mv, okay? Yes. I say doesn't matter, you call that positive momentum or this as positive, doesn't matter, okay? Any one you call positive, then returning back means second time it will be negative because velocity direction change, vector, so momentum direction also change. Okay, then we have to find time is given, we have to find force. We have this formula that force is simply equal to what? dp by what? dt, right? Rate of change of momentum. So we have found change in momentum is minus 2 mv, and time also we know, right? Time. Let's put all the values given. Minus 2, mass is given 150 gram. 150 gram is into 10 power minus 3 because you have tried in SI system. Okay, velocity is given what? 10 divided by time given 0.01 or 0.01, simply you can write 1 into 10 power minus 2, so that calculation becomes easy. Okay, minus 2 goes here, minus 1 remaining, that goes it here. So 150 into 2, that becomes what? 300 what? Newton. Correct. So sometime what I do, because I have to calculate fast, so I can do some calculation mistake. You should see this carefully, and if you find any such mistake, always put in comment. Okay, I will help you. Okay, let's go to one more problem, third problem. It says that this question is very interesting. Okay, this all type of questions they have asked in our exam, all these are patterns only. Okay, yes. Sometimes what happened, like here I said like this ball is coming straight and returning back straight, they did not give angle. Sometimes they can give angle like this way, that side comes at what? Some angle and return back. This angle is given 30 degrees, this angle is given 30 degrees, some angle is given to you. Then what you do? This is your momentum, this direction, you take component, this momentum become mv cos theta, the vertical momentum become what? mv sin theta. Then you take component this, that become minus mv cos theta, that become what? mv sin theta. The momentum y direction, initially mv sin theta downward, final also downward, right? Both are in same direction, change becomes what? 0 directly. Here change becomes what? Initially is mv cos theta, final is minus mv cos theta. So this becomes minus 2 mv cos theta, right? So angle also can be given, you can take component in that case, okay? Yeah, and similar question we will see again what a dual nature of 12th class, okay? Dual nature, when the rebounding of photon they ask, exactly same problem. So we are doing this problem, this is a very important problem. They said disk of mass m is kept floating in air by firing bullets of mass small m vertically at rate of what? n bullets per second. If bullets rebound with same velocity, find the velocity of bullets to keep the disk floating in what? Air. Okay, very interesting. Numerically was asked, and like this one as a formula it was asked. Both ways this question was asked. Okay, there is a disk of mass m. Yes, we keep floating this air. How? By firing bullets from down. We are firing some bullets. Okay, the bullet hit this and what? Rebound like this. Okay, yes, firing mass is given small m, velocity is given suppose v. Okay, we are firing bullets from down, they hit that plate and rebounds, so that we keep floating this in air. So it's very simple. What we are trying to do here, we are trying to balance the weight of this disk. This is a disk. Okay, yes, that weight is how much? So weight of disk, this is balanced by what? The force applied by this what? Bullets, right? Now force produced by what? Bullet. This is we doing. We keep floating this disk in air, means the weight of the disk is what? mg, and this is balanced with what? The force produced by what? This bullets. So weight of disk we know is what? mg. That's simple. Now you want to know what is the force produced by the bullets. So same formula, force is equal to what? Either dp by dt, correct? No? Yes. So I calculated a little separately. Okay. So what is the force produced by bullet? Look here. Let's first calculate change in momentum. While going momentum, I am saying mv. Okay. So while return, I should call it what? Minus mv. Velocity not changing, they are saying. So this momentum I am calling positive, then that momentum become what? Negative. Or this you call negative, then that you call positive. Doesn't matter. Always like this rebounding case becomes what? Double change in momentum. So first I am calculating what is change in momentum. It becomes what? 2 mv or minus 2 mv, doesn't matter. Okay, you can put minus also. If you call this positive, that negative, then become minus 2 mv. You call this negative momentum, that positive, then it becomes just 2 mv. We are talking about magnitude only, so just I am writing 2 mv. This is the momentum, change in momentum, right? Yes, this is change in momentum of what? Only one bullet. And how many bullets you firing? N bullets, keep in mind. So total momentum. Okay, let me write force due to one bullet first. Okay, force will be due to one bullet will be 2 mv by time t, correct? Yes, we writing this formula. Momentum by time is what? Your force. Now you have 4 n bullets. Okay, I have n number of the bullets, correct? Force will be, total force will be what? 2 mv by t into what? N, correct? Na? Yes, n is the number of the bullets you firing per second, right? This is the time. which is given 1 second, still we are writing time. Okay. So now we have to equate this. So I should write like mg, the weight of this disc is equal to force produced by these bullets, which is 2 mv n by what t, correct. Also listen, if you listen carefully, the bullets are given per second, so time is given what, 1 second. Okay. So you can put here 1, but this time could be anything. They say that n bullets are fired per minute. Here write your time here as in minute, means 60 seconds. Okay. They are asking us what is the velocity, right here, velocity equation. So let's find this your velocity. V should be equal to mg. So I am saying this, I am writing time as 1 because they said bullets are fired per second. Okay. So mg by 2 m and n, that's the velocity of the bullets, correct. At this speed you should fire the bullets so that this disc is kept floating in what, air. The weight of the disc is balanced by the force applied by these bullets. Okay. So again rebounding equation, change in momentum writing. Okay. Let's do one more problem here, fourth problem. This type of equation, a momentum is given by some equations given, and they are saying find the time when force is on this body is what, becomes 0. Momentum given is a variable, you can see varies with time, and we have to find what, force when the time when the force becomes 0. So first, what is force in terms of momentum? dp by dt, differentiation of the momentum. Okay, let's differentiate. When you differentiate that equation, you write d by dt of 10t cube plus 5t plus 6. Okay, let's differentiate. What is the answer? 10t square becomes 30 into t square plus this becomes what, 5, and 6 becomes what, 0. Okay. And the saying, what the saying? Find the time when force becomes 0. So equate this is equal to 0, right? F is equal to what? 0. So we get 30t square plus 5 is equal to what? 0, correct? Okay. So t square should be equal to what? Minus 5 by 30 minus 1 by 6. Now you see an interesting thing, like in this question some options were given. We got a negative answer of time, and time cannot be negative, right? Na? Time cannot be negative. So how they wrote option? They wrote some option like one correct option they wrote like that it will be force will be never 0, right? Na? We cannot find time because force will be never 0. Here you see that time increasing, this momentum keep increasing, and the force also what, keep increasing. There will no time when force becomes 0. So what was the answer of this question? Force will be never 0. Force will be never 0, because we are getting a negative time answer here. Negative time is what, not possible. So you cannot find time. So what was the answer of this question? Force will be never 0. Force will keep increasing with time, momentum increasing and force also increasing, right? So these were the 4 problems we have done on this what, Newton's second law and momentum together, right? So now we will move to our Newton's third law. As I told you that Newton's first law simply gives the definition of the force. It defines force. It said what is force? Force is something which can produce change in your state of rest, motion, or what direction, or can change the shape of the body, right? Similarly, then I said that Newton's second law gives how much force. It gives a formula to calculate force. Force is equal to what? dp by dt. Again we have two format, either velocity constant or mass constant. Mass constant, then force become ma, velocity constant then become v into what? dm by dt, right? Yeah. Similarly, now when we move to third law, Newton's third law. Okay. So we are talking about Newton's third law. Yes. Newton's third law is actually based on the conservation of the momentum. Okay, I will talk about that later. Let's first define how they say. Newton's third law you have learned in junior class also that for every action there is equal and opposite reaction. Let me write that simple definition here. For every action there is equal in what? Magnitude. Okay, yeah, equal in magnitude and opposite in what? In direction. Direction should be opposite, magnitude should be same, correct? Reaction. Okay, for every action there is equal which is in magnitude and opposite in direction reaction. Okay, yes, this is simple definition we have learned. And most simple way how you say that, like once more I say, Newton's first law, I say, defines force, give definition of force. Second law gives how much force, gives a formula to calculate. And third law talk about what? Conservation of the momentum. Main thing is what? We talk about what? Conservation of what? Momentum. How? Let's see. So suppose you have two bodies, two balls, something, they hit each other. The change in the momentum of this ball is called dp1, this ball you call dp2, correct? Yes. Our law of conservation of momentum, which we learn in next steps, which says that the total momentum of system, isolated system, should be what? Always constant or conserved. So how you say that? Change in momentum of this ball plus change in momentum of this ball should be what? Always constant, correct? It should be always constant or conserved. Or suppose initially they were 0, initially the final change should be also what? 0, like this way, okay? Yes. Or you can say change in momentum of first is equal to what? Change in momentum of what? Second, okay? Now from Newton's second, you know that force is what? dp by what? dt, correct? Yes, yes. So suppose you write by time you divide, like dt, same time you divide on both sides, then how you can say? Okay, this is nothing but what? F1, force applied by this body, then force applied by the second body. F1 will be equal to what? Minus F2. dp by dt is what? Force. Or you can say that simply F1 plus F2 is what? 0. Right? For every action, this is the action, force applied by body 1 on body 2. That is equal. Okay, magnitudes are equal and direction opposite, yes, without minus sign here, right? This is the meaning of what? Newton's third law, right? So the questions based on Newton's third law will be always with what? Conservation of momentum, okay? Because this is it coming from mainly conservation of the momentum, right? So we will do those things. Suppose, let's understand Newton's third law with this example. Suppose there is a rope, okay? There is a rope and two people are pulling this rope from both sides. One applying force here, let's say is F is 10 Newton. There is a person A here, and on the other end there is a person B which is applying force of what? Say 10 Newton, correct? This is a rope and on both sides we are applying some force, correct? Yes, this is a rope and on both sides we are applying some force, right? Person A, person B. Now I am saying that suppose when you are doing like this one, suppose this rope is stretched by some amount, okay? Say how much stretch here? I am saying X amount, okay? Yes, this is a case 1. Now what I do? Then I say that the same rope is fixed in a wall like this, okay? Same rope is fixed in a wall like this, and here we apply a force by person A alone, that how much? 10 Newton, okay? Then I am saying the extension in this rope is, let's say, amount X days, okay? Once more, let me clear this question. There is a rope, on both end of the rope there are two persons stretching from both sides with what force? 10 Newton, 10 Newton, say, okay, equal. In that case I am saying the extension in this rope is, say, what? X amount, okay? Then what I did, second case, this rope is fixed in a wall here, this is a wall, okay? And from only one end we are pulling it with what force? Same force, 10 Newton. Then I am saying the extension is what? X. Now question is this, whether extension, which extension will be more? X1 is more than X, X is more than X, or they are equal? What should be the answer? Pause this video and think for few seconds. What should be the answer? In which case the extension is more or they are equal? Okay, so the answer is what? This one, they are equal. Why they are equal? Because this and this are exactly same case. How? Here we are applying force on both sides, okay? Here is saying force we are applying one side, but at this point there is an action, there will be equal and opposite reaction. So there will be a force applied here, exactly same amount, 10 Newton in opposite direction. That's the what right, that direction will be right opposite to this, and magnitude will be exactly equal. So this case and this case are exactly same scenario, exactly same. You pull a rope from both end like this, or you fix in one wall and pull from one end, the result will be exactly same. Correct na? Yes. Because action and reaction, if this action, there is a reaction here always. Or like this way, suppose a block is placed here, this is what m kg, right? So this block is applying a force on this surface. How much force? mg, the weight of this block, right? mg. Then this block, the surface also apply force on this exactly in opposite direction. mg is here, exactly in opposite direction to this, and that's called what? Reaction, right? So this n will be simply equal to what? Your mg, equal and opposite. That's simple rule. Okay, yes. Okay, suppose I say that questions we have discussed based on rockets. When rocket is flying, this is a rocket, then what are we saying? The gases are burnt and they leaving this rocket with some velocity, right? So gases producing a force, you said force was V into dm by dt, and why you said like that? Because here velocity of gases into what? Rate of what? Fuel burn. Okay, then the action is there, which is called what? Thrust. Correct na? Thrust. This is a force produced, then additional force of which what is the weight of this rocket is capital mg. Correct na? Yes. So thrust produced here, okay, will be by this gases, and if this is more than or at least equal to what? The weight of the rocket, then rocket start flying. Or this value if is more than that, then rocket start what? Accelerating. Okay, if we say that V dm by this is the force produced by gases more than what? mg, then rocket start accelerating upward. Or they are equal, then start moving with a constant velocity upward, right? So this is action, we getting what? Reaction here as a thrust. Okay, yes. Okay, this was all about what? Newton's third law, and everywhere now what we doing, there will Newton's third law will be applicable always. Okay. So this we have done already the basic part, the first part where we learned Newton's three laws, first law, second law and third law, right? Okay, now we will talk about the applications of all these three laws together combined. So now the topic we starting is called FBD, free body diagrams. Free body diagrams. So what is this? This is nothing but a method to solve the problems. Okay, to solve the problems, any complex problem we can solve by using a simple principle called what? Free body diagrams. Why is called free body diagrams? Because in this type of in this method what we do, some bodies are given 2 body, 3 body or 100 body, doesn't matter. So what you do, you separate them, you take one body alone and you write the external forces acting on that body, and we solve that body alone, okay, separately. So we call it free because we are freeing that one body alone from remaining other bodies, okay, and we write then forces acting on that body, only what? External forces, internal forces it doesn't talk, okay, because all you learn internal forces doesn't affect your motion, yes. So we write external forces, then you write a net force acting is equal to either ma, if body is accelerating then write ma, or body is moving at constant velocity or at rest then write net force is equal to what? 0, correct. This force can be in x direction, it can be in what? Y direction, means body can be moving horizontally, if body moving horizontally write net force in x direction is equal to what? Ma, okay, or is moving in vertical direction then write net force in y direction is equal to what? Ma. If body is accelerating or body is not accelerating then you write what? Don't write ma, that a becomes 0, so net force should be equal to what? 0 if body is moving at constant speed or it has rest, or if start accelerating then you write net force is equal to what? Ma simply. Okay, before going to this one or two term I have to introduce with you, two words can come. One word is called inertial mass and one word will come is called what? Gravitational mass. So you should not confuse, they are same only. So how you say the inertial mass? When a body is accelerating, okay, then you say that is inertial mass, let's go write mi symbol, is equal to simply force acting by the acceleration of that body. If body is accelerating, then why you say inertial mass? force by acceleration of the body. Or what is gravitational mass? mg, let's call it force by what? Acceleration due to gravity. Correct? But in real, mi is always equal to mg only. That's all. So you should not confuse. They talk about this or this word. Okay, both mass are same thing only. Inertial mass is equal to what? Always gravitational mass only. But inertial will talk, then means acceleration of the body will come, and when I talk about gravitational means acceleration due to gravity will come, right? Okay, so now we start the second chapter, which is called free body diagrams.